Good morning, students. So let us start with the today's class. So yesterday we have started with the ray optics. So what is ray optics? What is reflection of light? Laws of reflection we have studied. So according to laws of reflection, the angle of incidence is equal to angle of reflection. Then next, second law, what it states? At the point of incidence, the incident ray, the normal drawn and the reflected ray all lie on the same plane. That is the second law. Then after reflection of the light, we have discussed about some of the sign conventions. Yes, so for the sign convention, here we have one figure to remember. Idರಲ್ಲಿ 7 terms related to the mirror. There are two types of mirror, concave mirror and the convex mirror. So in the concave mirror or in the convex mirror, we discussed 7 terms like aperture, what do you mean by pole, center of curvature, radius of curvature, focus, focal length. So total 7 terms also we have discussed. Then next, the sign convention. So in the sign conventions, mainly we have the 4 points. The first point is all the measurements are done from the pole. So pole is like a origin. Then after that, right side measurements are taken as positive. The left side measurements are taken as negative. So if you consider this as a mirror, this is the pole. All the measurements are done from the pole. The right side measurements are taken as positive. The left side measurements are taken as negative. The above measurements are taken as positive. The below measurements are taken as negative. Okay. So these points we have discussed. Then after that, the next what we are going to see today is okay, let us see the next point now. So whatever the sign conventions we have discussed, it is also called as the Cartesian sign conventions. Okay, so sometimes they will ask you to write for the 2 marks, write the Cartesian sign conventions used in the mirrors. So total 4 points, remember that. So now, yesterday we discussed 7 terms. In that, let us see 2 terms, that is the focal length and the radius of curvature. The focal length and radius of curvature. So what is the relation between the focal length and the radius of curvature? Here the relation between the focal length and the radius of curvature is given by, so we can do the derivation. Actually in 10th standard you might have studied the formula. You can see here how to do the derivation, students. So for that we are considering a mirror. So consider the XY as a mirror. Then next here, this is a pole. This is the incident ray. Incident ray. This incident ray after reflection is passing through the focus. So this is the focus point. Here we have the center of curvature. I'll show the center of curvature to the mirror, the dotted lines. So L, M, here one perpendicular I am taking, that is D. And this angle is theta. This angle is also theta. So according to the theorem, here this angle becomes 2 theta. The next, so this is the center of curvature point. This is center of curvature. So you know that the distance between the center of curvature and the pole is called as the radius of curvature. The distance between the pole and the focus is called as the focal length. Yep, is called as the focal length. Yep, okay. So now from the figure here, students. So first see in terms idanta XY. XY is the aperture, or you can say that it is a concave mirror. So XY is your concave mirror. XY is the concave mirror. LM is the incident ray. Here LM is what? It is the incident ray. LM is the incident ray. Then next CM. So here you can see C to M. You can observe in the diagram. So even CM nodta idira. It is like a normal to the surface. It is normal to the reflecting surface. MD is the perpendicular drawn. MD is the perpendicular drawn. It is the perpendicular. Theta is the angle of incidence. Theta is the angle of incidence. Here F is denoted for the focal length. Yes. So here you can observe here students. ಏನೆಲ್ಲ ಬರ್ದಿದೀವಿ ನೀವೆಲ್ಲ ಫಿಗರ್ ಅಲ್ಲಿ ನೋಡ್ತಾ ಹೋಗಿ. So XY ಅನ್ನೋದೇನಿದೆ, it is a concave mirror. LM ನಿಮಗೆ ಇಲ್ಲಿ LM ಕಾಣಿಸ್ತಾ ಇದೆ. This is L. So this LM is the incident ray. So ಇಲ್ಲಿ angle of incidence, ಇಲ್ಲಿ theta ಇದೆ with the normal. So with the normal, this is the theta angle is the angle of incidence. So according to the that is alternate angles. So here you can see. So this is also theta. So idu theta ide. What about this angle? So it becomes 2 theta. Yes. So now from these triangles, let us do the derivation to see the relation between focal length and the radius of curvature. Gottaita en ಮಾಡ್ತಾ ಇದೀವಿ? We are doing the relation between the focal length and the radius of. Yes. See. So for that, I'm considering the triangle. In the triangle CDM. In the triangle CDM, that is tan theta is equal to. So from the triangle CDM. So you can see figure there. Please tell me what is tan theta. Yes, it is from the figure. Hope so you are able to see the triangle. If you want, I'll draw it here. See. So CDM andre ee tara ide adu. C, this is M, this is D. So CDM alli tan theta is equal to kelta idivi. So tan theta is equal to, from the figure, it is MD divided by CD. It is MD divided by CD. This is equation 1. So now from the triangle FMD, now from the triangle students, that is FMD, tan 2 theta is equal to. So from the triangle, so this is theta. ಈಗ ಈ triangle consider ಮಾಡ್ತಾ ಇದೀವಿ. This is 2 theta and this is FDM. Okay. So from this triangle, tan 2 theta is equal to. So tan 2 theta is equal to what we can write. See here, tan 2 theta is nothing but what? It is FD divided by, here it is MD divided by FD. This is equation 2. Okay. So now, whatever equation 1 and 2 is there. So from the equation 1 and 2, yes, Sri Varuni is present today. Why is college is holiday? Okay, okay. Yes. So from these two triangles, we have written MD by CD, MD by FD. Okay. So here, whatever the angle is there, so we will consider yav angle nota idivi figure alli, those are very small angles. So therefore the tan theta is nearly equal to theta anta helbodu, and tan 2 theta is nearly equal to 2 theta anta matra now will consider madbodu, because those are very small angles. Okay. So as the rays are very close to the principal axis, we can consider the angles are very small. So therefore now, see. So equation 1 ಏನಾಗುತ್ತೆ, tan theta ಇದ್ದದನ್ನ theta ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ. Therefore it becomes theta is equal to MD divided by CD. and 2 theta is equal to, it is md divided by fd. So this is equation 3, this is equation 4. Okay, so equation 3, 4 admele. Now what we are going to do is dividing 4 by 3. The next step, last step for the derivation. Very simple derivation. 4 divided by 3 madi. So what we will get here, students? 4 divided by 3 madidre theta theta will get cancelled. So uliyatene ಏನು ಉಳಿಯುತ್ತೆ 2. ಹೌದಾ? Because theta theta will get cancelled. MD will also get cancelled. So 4 divided by 3 ಮಾಡಿದೀವಿ. Therefore it will be CD divided by FD. So the remaining term is what? That is CD divided by FD. Now you can see from the figure. Now come to the figure. So figure al nodi CD. If you see CD, D point is very close to P. What I am saying here, allen D perpendicular then D point ide adu edakke very close ide students, ಇಲ್ಲಿ pole close ide ಹೌದಾ? Pole ಮತ್ತೆ D point very close ಇರೋದ್ರಿಂದ so CD now nearly equal to CP ಅಂತ ಹೇಳ್ಬೋದು. CP ಏನಂತ ಹೇಳ್ತಾ ಇದೀವಿ? The distance between the center of curvature and the pole is called as what? Radius of curvature, right? It is called as the radius of curvature. So you can write the CD value as R. Okay, divided by FD. So what is FD? F to D. Again, D point is very close to the point P. ಹಾಗಾಗಿ ಅದು focus ಮತ್ತೆ pole ಮಧ್ಯ distance ಅನ್ನ focal length ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ. Therefore we can write it as R divided by F, or we can simplify it as what? F is equal to R by 2, relation between focal length and the radius of curvature, or R is equal to 2F, or R is equal to 2F. So in 10th standard, you have studied the direct formula. Today here you can see the proof. What is the relation between the radius of curvature and the focal length? Radius of curvature and focal length. See. So simple is the derivation in tough illa. Just you have to draw the diagram clearly. Diagram onsali draw madidmele what you need to do. Here once you do the labeling properly, the simplification will be easy. So once we are taking CDM triangle, once we are taking FDM triangle. FMD triangle. Tan theta, tan 2 theta. So take the ratios, the derivation is over. Okay, so here if you are feeling il bhala hing kansta ide antandre simple agi nimge derivation heltini nodi. So what we are doing, so we are considering the concave mirror. LM is our incident ray. So this is the normal drawn. The normal we are taking it from the center of curvature point. This is the angle theta. This will be also the angle theta. Here the this is incident ray. The reflected ray is passing through the focus. Okay, so focus in the pass ಆಗ್ತಾ ಇದೆ. ಮತ್ತೆ ಈ angle ಏನಿದೆ 2 theta ಅಂತ ಇದೆ. From M we are taking one perpendicular, that is D. ಇದು ನಮ್ದು pole point. Okay, so from the pole the focus ಇದನ್ನ focal length ಅಂತ ಹೇಳ್ತಾರೆ. From the center of curvature, pole is called as the radius of curvature. Okay, now from the figure, the triangle tan theta is equal to ಯಾವ triangle ತಗೊಳ್ತೀವಿ? CMD triangle. ಏನ್ ಬರುತ್ತೆ? It is MD divided by CD, equation 1. If you go for tan 2 theta, it is again MD divided by FD. This is equation 2. So you can write one sentence. Ilen baritira, theta is nearly equal to, sorry, tan theta is nearly equal to theta, and tan 2 theta is nearly equal to 2 theta. ಹಾಗಾಗಿ CD is equal to ಏನಾಗುತ್ತೆ? MD by CD ಮತ್ತೆ 2 theta is equal to MD divided by FD. Equation 3, equation 4. So 4 by 3 ಮಾಡಿದ್ರೆ we will get it as 2 is equal to CD divided by FD, which is equal to R divided by F. Simple derivation. So final formula is what? R is equal to 2F anta helbodu, or you can say F is equal to R by 2. Yes, if anybody is having any doubt in any of the steps, ask. Otherwise, please copy down the derivation part. Yes, completed everyone. Then next we will see the mirror formula. Okay, again for the mirror formula, first we will see the diagram, then diagram explanation, then the derivation part. Okay. So if you go through the ray optics deleted part, here refraction is deleted, total internal reflection do in application ide like mirage, diamond, some natural phenomena, rainbow, scattering of light, Doppler effect, interference of light, adu idral barutte. Okay, so these many points are deleted from this chapter. So the derivation yavdu delete agilla. So illi 3 derivation barutte, 4 derivations will be there. Idantu small derivation, bandru bantu illa, just you remember the relation. Okay. So relation derivation part, prism formula, lens makers formula. Now we are doing mirror formula. These are the important derivations. Okay, so this is completed. Now we will go for the next derivation, students. See here, the next derivation is, that is, derive the equation in case of the concave mirror producing real image. So we are seeing the mirror formula now. We are considering it for the concave mirror. Okay, so first see the figure here. The derivation heading is, it is the mirror formula. So mirror formula for the concave mirror we are doing. So consider the principal axis, a concave mirror. Okay, so this is the point P. This is the incident ray. The next reflected ray we are taking. So the reflected ray, it is passing through the focus. Here one more incident ray we are taking. This is AB, is the object which is placed in front of the mirror. So this is AB, object is placed in front of the mirror. So adralli one incident ray illi parallel to the principal axis after reflection passing through the focus. One more incident ray we are considering, which is making some angle with the principal axis theta. After reflection, it will pass and makes the angle theta itself. Then next, one more ray we are taking. So the third ray, which is passing through the center of curvature, which is passing through the center of curvature. After reflection, it will return back in the same path. So this is the incident ray, this is the reflected ray. Here you can see all the 3 rays. Okay. So actually whatever this ray is there, ee ray kuda illindane pass agbeku, because I want to show you all the 3 rays are meeting at one particular point. So if you have not understood the figure, once again I am explaining you the figure, students. The principal axis, concave mirror, so here we have the principal axis. This is the concave mirror and this is the incident ray. This AB is the object. So incident ray parallel to the principal axis iddaga, it will pass through the focus after reflection. So this is incident ray, reflected ray. Mattond ray consider ಮಾಡ್ತಾ ಇದೀವಿ, which is passing through the center of curvature, which is passing through the center of curvature. ಮತ್ತೆ ಇಲ್ಲಿ ಮಿರರ್ ಗೆ ಬಂದು ಹಿಟ್ ಆದಾಗ it will travel back in the same direction. Okay, next one more ray we are considering. ಆ ಥರ್ಡ್ ರೇ ಏನಾಗ್ತಾ ಇದೆ ಅಂತ ಅಂದ್ರೆ, here it is making some angle with the principal axis. The third ray we are considering. So this is the incident ray. Here you can consider the angle of incidence theta. After reflection, it will also go, and all the three rays after reflection, it is meeting at one point. You can see here. So figure ಸ್ವಲ್ಪ ಇದು after reflection. This is reflected angle. This is incident angle. So ಅದು ಈ ತರ ಇದೆ. Okay. This is principal axis. Here angle of incidence. Here angle of reflection. That we are considering it as what? Theta theta here. So ಇದ್ರದ್ದು ಏನ್ summary ಅಂತ ಅಂದ್ರೆ, what I want to tell you is after reflection, all the three rays, which all three rays, one do passing through the center of curvature, returning back in the same direction. One more angle of incidence in the incident agi reflect ಆಗ್ತಾ ಇದೆ, that is the second ray. One more is passing through the focus. So all the three rays are meeting at this point. Here you can see in this figure, here it is there. All the three rays are meeting at this point where the image we can see. So ideal meet ಆಗ್ತಾ ಇದೆ after reflection, all the three rays, there we are able to see the image. So here this is A dash and here it is D dash, and the inverted form alli namge image barta ide. Okay, so this is the figure what you need to understand. Yes, figure is clear to everyone? So you see the figure. If any doubt is there, you tell me. Till that I label this. XY is the mirror, P is the pole. Then next, this is center of curvature. So from the center of curvature, it is radius of curvature. Matte AB object ide. So pole in the measurement ಮಾಡ್ತೀವಿ. This is called as the object distance U. This is called as object distance U. Matte L image form agide, that is called as image distance V. And the distance between the pole and the focus is called as the focal length. Yes, in the figure any doubt is there? If any doubt is there, once again I'll tell you. Yes, please tell me if any doubt is there for the figure. You are free to ask. Actually, in 10th standard, you will study about the image formation. I don't know you remember or no. So ಅಲ್ಲಿ ನಾವು 4 formulas ಅನ್ನ ಹೇಳ್ತೀವಿ, 4 rules ಅನ್ನ ಹೇಳ್ತೀವಿ for the image formation. What is that? If you want, once I'll revise that. ಏನಿದೆ ಅಂತ ಅಂದ್ರೆ, here I'll consider concave, convex. ಯಾವ್ದು ಮಿರರ್ ಬೇಕಾದ್ರೂ ತಗೊಳ್ಳಿ. Okay. So according to those laws, here the first law ಏನ್ ಹೇಳುತ್ತೆ ಅಂತ ಅಂದ್ರೆ, object ಇಂದ ಏನ್ incident ray ಹೋಗ್ತಾ ಇರತ್ತೆ. So we know that one object ಅನ್ನ ನಾವು ಮಿರರ್ ಮುಂದೆ ಇಟ್ಟಾಗ it will give out n number of rays. ಹೌದಾ? So object ಇಂದ n number of rays ಬರ್ತಾ ಇರತ್ತೆ. ಅದ್ರಲ್ಲಿ we need to see 4 rays first. So first ಏನ್ ನೀವು observe ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ, whether the ray is parallel to principal axis or no. So ಎಲ್ಲಾ rays parallel to the principal axis ಇರಲ್ಲ. There are only few rays which are parallel to the principal axis. So which is parallel to the principal axis, after reflection it pass through the focus. This is first law. The rays which all are parallel to the principal axis always pass through the focus after reflection. Second law ಏನ್ ಹೇಳುತ್ತೆ ಅಂತಂದ್ರೆ, ಇದ್ರದ್ದು ರಿವರ್ಸ್ ಅಂದ್ರೆ, the ray which is passing through the focus, the ray ಆ object ಇಂದ the ray which is passing through the focus ಅಂದ್ರೆ incident ray focus ಇಂದ ಹೋಗ್ತಾ ಇದೆ. After reflection, mirror hit agi after reflection, it goes parallel to the principal axis. So first in helidvi, the ray which is parallel to the principal axis after reflection passing through the focus. Second in helta idivi, the ray which is passing through the focus after reflection goes parallel to the principal axis. Third, so third what it is there, the ray which is showing some angle of incidence with the principal axis. Idu incident ray aitu. Here the object is there. After reflection, according to the law, it will go out with some angle of refraction. So this is angle of incidence, this is angle of refraction. Fourth, the ray which is passing through the center of curvature, reflection ಆದ್ಮೇಲೆ same direction ಅಲ್ಲಿ return ಹೋಗುತ್ತೆ. Reflection ಆದ್ಮೇಲೆ after reflection goes in the same direction. So these are the 4 laws which we study in the 10th standard. So ನಾವು ಇದ್ರಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕು ಅಂತ ಅಂದ್ರೆ you have to observe where minimum 2 rays are meeting. So ಎಲ್ಲಾ rays parallel ಇರಲ್ಲ, ಎಲ್ಲಾ rays passing through focus ಇರಲ್ಲ, ಎಲ್ಲಾ rays passing through the center of curvature ಇರಲ್ಲ. There are only few rays which are following these 4 laws here. So ಅದ್ರಲ್ಲಿ 4 ಅಲ್ಲಿ minimum 2 after reflection minimum 2 rays meet at one point. Minimum 2 rays meet at one point. So minimum 2 rays ಯಾವ one point ಅಲ್ಲಿ meet ಆಗತ್ತೆ ಅಲ್ಲಿ ನಮ್ದು image formation ಆಗತ್ತೆ. There we can see the image formation. Understanding students where the image formation is there? So in this figure ನಮ್ದು mirror formula ದಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ 3 rays are meeting at the image formation. ಯಾವ್ದ್ಯಾವ್ದು? one ray which is parallel to the principal axis passing through the focus, matondu which is showing some angle of incidence, angle of reflection in the pass ಆಗ್ತಾ ಇದೆ. One more is passing through the center of curvature, returning back in the same direction. So here all the 3 rays are meeting at one point where the image is formed. Please tell me any doubt is there in the 4 rules or the image formation of the mirror formula. You want me to repeat any point or is it clear? Yes. Harshita, Charan, Baby, Srivarni. Any doubt? Clear everyone? Okay, yes. If any doubt is there, please ask. So now, so we will see one proper diagram so that we can proceed with the derivation. So you can observe if you want once again, this is the XY is the concave mirror, P is the pole. So here we can see this is AB is the object. The next ray I am taking parallel to the principal axis, incident ray, reflected ray. So this is the incident ray. This is the focus. This is the reflected ray. Next, the ray which is going parallel to, not parallel, passing through the center of curvature. After reflection goes back in the same direction. So now here you can see all the 3 rays are meeting at one point. Here. So here we are able to see the inverted image. This is B dash, this is A dash. So now whatever the distances are there, we will write it. So from the object to the pole. So object distance anna now U in the denote ಮಾಡ್ತೀವಿ. Image L form ಆಗಿದೆ. From the pole the distance is taken as V, object distance, image distance. Focal length ಇಲ್ಲಿ ಬರುತ್ತೆ. Radius of curvature here it will be there. Now let us start with the derivation here, students. Okay, so now yes, XY is the concave mirror, AB is the object, A dash, B dash is the image. So there we have AM is the incident ray, AP is also the incident ray. Then next AN is also the incident ray. So from the similar triangle properties here, if I consider the triangles ABP and A dash, B dash, P dash. So if you observe the figure, you can see A B P ಒಂದು ಟ್ರಯಾಂಗಲ್ ಕಾಣ್ತಾ ಇದೆ ನಿಮ್ಗೆ ಫ್ರಮ್ ದ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಆಬ್ಜೆಕ್ಟ್, and A dash B dash P, that is with respect to the image. These are the two triangles which you can see here. So ಒಂದು ಈ ರೀತಿಯ ಕಾಣ್ತಾ ಇದೆ, ಮತ್ತೊಂದು ಕೆಳಗಡೆ ಕಾಣಿಸ್ತಾ ಇದೆ, ಹೌದಾ? So these two are the similar triangles. According to the similar triangles properties, we can write it as A dash B dash divided by A dash B dash divided by AB is equal to P dash, sorry, P B dash divided by PB. This is my equation 1. Hope so it is clear to you how we have written the equation 1. Equation 1 we are writing based on the, that is similar triangle properties. See there. That is from the similar triangles with respect to the object and the image. A dash B dash divided by AB is equal to BP dash divided by PB. Equation 1. Now we are considering one more similar triangle. This is equation 1. So see, so derivations are based on trigonometric functions, trigonometric theorems, and the geometric theorems. Geometry use ಮಾಡ್ತಾ ಇದೀವಿ. So ಸ್ವಲ್ಪ ಟಫ್ ಆಗುತ್ತೆ, ಯಾರಿಗೆ ಸ್ವಲ್ಪ ಕ್ಲಿಯರ್ ಆಗಿ ಬರಲ್ಲ ಟ್ರಯಾಂಗಲ್ಸ್ ಎಲ್ಲ, ಬಟ್ ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹಿಯರ್. ಸೊ ಈಗ ಏನ್ ಮಾಡಿದ್ವಿ, ಫಸ್ಟ್ ಟ್ರಯಾಂಗಲ್ಸ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಆಬ್ಜೆಕ್ಟ್ ಅಂಡ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಇಮೇಜ್. ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ಪ್ರಕಾರ ಇಕ್ವೇಶನ್ 1 ಬಂದಿದೆ. ಮತ್ತೊಂದು ಫಿಗರ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಅಗೈನ್ ದಟ್ ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ಸ್ F P M, F P M. You can see the one more similar triangle F P M and F A dash B dash, F A dash B dash, F P M and F A dash B dash. These are the two similar triangles again we are considering. So from this again we are writing according to the properties. It is A dash B dash is divided by PM. So M will be here, okay? So nimge M naan first figure alli helidde incident ray idi M, okay? So M F B, this is M, this is F, this is P. A dash B dash divided by PM is equal to F B dash divided by P F divided by PM. Okay, so I'll make it as equation 2. This I'll make it as equation 2. So now from the equation 2 we can also write it as A dash by B dash, A dash B dash divided by PM. PM ಏನಿದೆ that I'll write it as equal to AB. Which is equal to F B dash divided by PF. This is equation 3. Why? Because PM is equal to, it is AB. You can see from the figure. Illen object height niಮಗೆ ಕಾಣಿಸ್ತಾ ಇದೆ. What you are observing the object height AB. Whatever your PM is there, PM. So ಎರಡು almost ಇದೇನಾದ್ರೂ straight path ಇದ್ರೆ ಇದು ಎರಡು ಸೇಮ್ ಬರುತ್ತೆ almost. Therefore FM we are considering nearly equal to AB. FM not PM. PM is nearly equal to AB ಅಂತ ತಗೊಳ್ತೀವಿ. That is our equation 3. So now if I compare equation 1 and 3 students, 1 and 3 compare ಮಾಡಿದ್ರೆ ಏನಿದೆ ನೋಡಿ. Here we have A dash B dash by AB is equal to ಇದೆ, and here equation 3 also A dash B dash is by AB. So both the side, both the equation 1 and 3 LHS is same. Equation 1 ಮತ್ತೆ 3 ದಲ್ಲಿ equation 1 and 3 LHS ಸೇಮ್ ಇದೆ ಕರೆಕ್ಟಾ. LHS ಸೇಮ್ ಇರೋದ್ರಿಂದ RHS ವ್ಯಾಲ್ಯೂಸ್ ವಿ ಕ್ಯಾನ್ ಈಕ್ವೇಟ್. Yes, RHS values we can equate. Copy down this much. Then RHS equate ಮಾಡಿ equation ಅನ್ನ simplify ಮಾಡಿದ್ರೆ we can come to the derivation. We can end the formula. So please copy down up to equation 3. If any doubt is there in the equation 3, please ask. So equation 1 ಬರಿಬೇಕಾದ್ರೆ we have considered the similar triangle ABP and A dash B dash P. Equation 1 ಬರ್ದ್ವಿ. ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀವಿ, ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಫೋಕಸ್ ನಾವು ತಗೊಳ್ತಾ ಇದೀವಿ ದ ಟೂ ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ಸ್. ಸೊ ಇಕ್ವೇಶನ್ 2 ಬರುತ್ತೆ ಅಂಡ್ ಇಕ್ವೇಶನ್ 3 we are just writing PM is equal to AB. So please write up to equation 3. Once you finish it, please tell me, we will write the next step. Yes, okay. Okay, so now as I told you, we are just taking the RHS terms, those are equals. So ನಾನು ಅಲ್ಲಿಂದ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಇಕ್ವೇಶನ್ 1 ಮತ್ತೆ ಇಕ್ವೇಶನ್ 3 ನಿಮ್ಮ ಹತ್ರ ಆಲ್ರೆಡಿ ಬುಕ್ ಅಲ್ಲಿ ಇದೆ. ಸೊ ಇಕ್ವೇಶನ್ 1 ಮತ್ತೆ ಇಕ್ವೇಶನ್ 3 ಪ್ರಕಾರ, ಸೊ ಹಿಯರ್ ವಿ ವಿಲ್ ಹ್ಯಾವ್ ಎಫ್ ಬಿ ಡ್ಯಾಶ್ ಅಪಾನ್ ಪಿ ಎಫ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಬಿ ಪಿ ಬಿ ಡ್ಯಾಶ್ ಅಪಾನ್ ಪಿ ಬಿ. ದಿಸ್ ಇಸ್ ಆಫ್ಟರ್ equating equation 1 and 3 RHS side. Okay. ಸೊ ಈ ಕಡೆ ಟರ್ಮ್ ಅದೇ ರೀತಿಯಾಗಿದೆ, ಪಿ ಬಿ ಡ್ಯಾಶ್ ಅಪಾನ್ ಪಿ ಬಿ ಈಸ್ ಈಕ್ವಲ್ ಟು. ಸೊ ನಾವು ನಿಮ್ಮ ಹತ್ರ ಫಿಗರ್ ಇರ್ಬೋದು, ಗೋ ಥ್ರೂ ದ ಫಿಗರ್ ಹಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಎಫ್ ಬಿ ಡ್ಯಾಶ್ ಅನ್ನೋದೇನಿದೆ, ಐ ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆಸ್ ಪಿ ಬಿ ಡ್ಯಾಶ್ ಮೈನಸ್ ಪಿ ಎಫ್ ಡಿವೈಡೆಡ್ ಬೈ ಪಿ ಎಫ್, ಕೀಪ್ ಇಟ್ ಆಸ್ ಇಟ್ ಇಸ್. ಸೊ ಫಿಗರ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಏನ್ ಹೇಳುತ್ತೆ, ನಮ್ಗೆ ಏನ್ ಬೇಕೋ ಅದಷ್ಟೇ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. ದಿಸ್ ಇಸ್ ಪಿ and here we have B dash, A dash. Here we have the F point. So F P B dash, F B dash. So see. So see, from the figure, you can see F B dash here now. So F B dash, can we write it as P B dash minus P F? Yes, check. ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, F B dash, suppose if it is 3 centimeter. Okay, so this is 3 centimeter. The full is 10 centimeter. So what will be the remaining? 10 minus 3 is, that is 7 here, correct? So ಈ ರೀತಿಯಾಗಿ ಬರ್ದಿದ್ದೀವಿ ನೋಡಿ. So 3 can be written as 10 minus 7. Yes, 7 can be written as 10 minus 3. Okay. Yes. See. Yes. Is it clear how to write f b dash? Okay, f b dash we can write it as pb dash minus pf divided by pf. Okay. So now, yes, ಇಲ್ಲಿವರೆಗೆ ಅಷ್ಟೇ ಇದು ತಪ್ಪಿದೆ. The remaining steps we are just substituting the values ನೋಡಿ students. ಆಯ್ತಾ? So ನಿಮ್ಮ ಹತ್ರ figure already ಇದೆ. So pb dash, if you observe what is pb dash here? So if you see pb dash ಅನ್ನೋದು ಏನಾಗುತ್ತೆ, image form ಆಗಿದೆ. So ಅದು image distance ಆಗುತ್ತೆ. Therefore the image distance is written as v. ಹೌದಾ? But left side measurement ಇರೋದ್ರಿಂದ we write it as minus v minus pf. If you see pf, it is focal length. ಹೌದಾ? So again it is a left side measurement according to sign convention minus f ಅಂತ ಬರೀತೀವಿ. Already one f ಇದೆ and this is also minus f divided by pf. So pf is again it is f ಮತ್ತೆ left side measurement ಇರೋದ್ರಿಂದ according to Cartesian sign conventions it is minus f. So which is equal to now pb dash. So what is pb dash? Again pb dash is the image distance. So image distance is v and again it is a left side measurement, take it as minus divided by pb. What is pb? Image object distance, it is u. So see, ಯಾರಿಗೆ ಇದು ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಪ್ಲೀಸ್ ಕೇಳಿ ಸ್ಟೂಡೆಂಟ್ಸ್. ಸೊ ಪಿ ಬಿ ಡ್ಯಾಶ್ ಅನ್ನೋದೇನಿದೆ ನಮ್ದು ಇಮೇಜ್ ಡಿಸ್ಟೆನ್ಸ್ ಇರೋದ್ರಿಂದ ವಿ ಅಂತ ತಗೊಳ್ತೀವಿ. ಪಿ ಬಿ ಇಸ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ವಿಚ್ ಇಸ್ ಟೇಕನ್ ಆಸ್ ಯು. ಪಿ ಎಫ್ ಇಸ್ ದಿ ಫೋಕಲ್ ಲೆಂತ್. ಪಿ ಎಫ್ ಇಸ್ ದಿ ಫೋಕಲ್ ಲೆಂತ್ ವಿಚ್ ಇಸ್ ಎಫ್. ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಲ್ ದೀಸ್ ಒನ್. ಎಲ್ಲ ಲೆಫ್ಟ್ ಸೈಡ್ ಮೆಜರ್ಮೆಂಟ್ಸ್ ಇರೋದ್ರಿಂದ ಆಲ್ ವಿಲ್ ಬಿ ಮೈನಸ್. ಆಲ್ ವಿಲ್ ಬಿ ಮೈನಸ್. ಎಸ್. See if any doubt is there, here also minus. Object distance ಕೂಡ ಮೈನಸ್ ಬರುತ್ತೆ. ಸೊ ಯಾರಿಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಿಳಿಯಿಲ್ಲ ಪ್ಲೀಸ್ ಕೇಳಿ. ಅಂಡ್ ಹಿಯರ್ ಮೈನಸ್ ಬೈ ಮೈನಸ್, ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಪ್ಲಸ್, therefore it is v by u. And here if you write it, it is minus v minus into minus plus f divided by minus f. Close. Please check. ಯಾರಿಗೆ ಯಾವ ಟರ್ಮ್ ತಿಳಿಯಿಲ್ಲ ಪ್ಲೀಸ್ ಕೇಳಿ. Actually it is simple, but only because of sign convention and more substitutions ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆಗೋ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಇಲ್ಲ ಅಂದ್ರೆ ತಿಳಿಬೇಕಾದ್ರೆ ತಿಳಿಯುತ್ತೆ, ಮಾಡ್ಬೇಕಾದ್ರೆ ಬರಲ್ಲ ನೋಡಿ. ಆ ತರ ಇದೆ ಡೆರಿವೇಶನ್. ಹೌದಾ? ನಾವು ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಆನ್ ಬೋತ್ ದ ಸೈಡ್. ಸೊ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ u into bracket minus v plus f is equal to minus v into f is minus vf. So uv is nothing but minus uv plus in this is plus uf is equal to minus vf. Now dividing the last step, dividing on both the side by uvf. Dividing on both the side by uvf. So ಎರಡು ಕಡೆ uvf ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ here it is first term ಅಲ್ಲಿ ನೋಡಿ, this is minus uv upon uvf plus uf divided by uvf is equal to minus vf divided by uvf. So ಇಲ್ಲೇನಾಗುತ್ತೆ, ಸೇಮ್ ಟರ್ಮ್ಸ್ ಅನ್ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿ the derivation is over. So here uv will get cancelled, u will get cancelled, v will get cancelled, f. So first term ಅಲ್ಲಿ ಏನು ಉಳಿದಿದೆ? Nothing is there, minus ಇದೆ, ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ 1 ಇದೆ, divided by f plus here numerator ಏನು ಇಲ್ಲ, plus 1 divided by v is equal to ಇಲ್ಲಿ ಮೈನಸ್ ಉಳಿದಿರುತ್ತೆ, minus 1 divided by u. ಸೊ ಜಸ್ಟ್ ನಾನು ಮೈನಸ್ ಟರ್ಮ್ಸ್ ಅನ್ನ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. minus 1 by f ಇದ್ದದನ್ನ ಈ ಕಡೆ ತಗೊಂಡ್ರೆ plus 1 by f ಆಗುತ್ತೆ. minus 1 by u ಇದ್ದದನ್ನ ಈ ಕಡೆ ತಗೊಂಡ್ರೆ plus 1 by u ಆಗುತ್ತೆ. So this is the mirror formula, that is 1 by v plus 1 by u is equal to 1 by f. So if you have not understood any step, please ask students. So first step, use similar triangle properties. So first with respect to object, first with respect to image, ಎರಡು triangles ತಗೊಳ್ಳಿ, ಅದ್ರ ಪ್ರಕಾರ theorem ಪ್ರಕಾರ ಬರ್ಕೊಳ್ಳಿ, equation 1 ಬರುತ್ತೆ. Equation 2, with respect to focus, two triangles you are considering, similar triangles, write down equation 2. ಅಲ್ಲಿ PM ಅನ್ನ FAB ಅಂತ equate ಮಾಡ್ಕೊಳ್ತೀರಾ. Then after that, RHS terms are same, therefore LHS are same, RHS ಅನ್ನ equate ಮಾಡ್ಕೊಳ್ತೀವಿ, that is equation 4. Next, we are substituting the terms. Then lastly, dividing by UVF, we come across mirror formula. So if anybody is having any doubt, please ask. So this is the mirror formula derivation, 3 marks. If any doubt is there, ask. Otherwise, we will continue in the next class with the next derivation. Yes, no doubts? Okay, students, we will meet in the next class. Thank you.